My name is Cullen Dejan, Senior Startup Solutions Architect here at AWS. And I'll be joined by Vinay Watt, the Director of Product for Databricks. And he's going to discuss the journey Databricks has gone modernizing and building out data architectures as they grew from a startup to what they are now as a large digital native business.
Oh, test. Okay, cool. Quick intro. My name is Vinay. I've been with Databricks for over 3.5 years now, roughly. My role in the company is that I look at after all things platform infrastructure and security. So the compute platform, networking, storage, encryption, key management, compliance, those kind of things. I manage the roadmap for that in the company. And joining me today is Ihor Leshko, who is the Director of Engineering who runs our compute platform. He's sitting right here in the first row. He will be available to answer any questions related to the engineering topics we discussed today. And lastly, Jeff Pang, who's the principal engineer, has been with Databricks for nearly, I don't know, it's probably over 6 years now, and has been instrumental in building out some of the infrastructure that we have today. He had helped me build these slides, so I wanted to acknowledge his name here as well. All right, so let's, a quick sort of intro on Databricks. As you know, Databricks has been founded, I think, 2013 by the founders of Apache Spark. And since that time, Databricks has built a lot of open source projects that you probably have heard of, like Delta Lake, MLflow, Koalas, and things like that. And as a company, we have grown to over 5,000 plus customers, and we've done that in a span, like in a short amount of time. And we serve over 40% of the Fortune 500 companies today. Apart from that, we're a startup, but we're growing really fast. We are over 2,300 employees at this point, and over 600 million in annual revenue. So what do? Well, our data platform provides analytics tools and AI and machine learning to data scientists, data engineers, and business users in the enterprise. It includes a data science workspace that integrates with things like notebooks, MLflow, TensorFlow, and things like that. And it has a unified data service that's built on top of Apache, Spark, and Delta Lake. It's also delivered as an enterprise cloud service, which is simple, scalable, and secure because we manage that data platform for our customers, right, with Databricks. So what's in this talk? Well, I'm going to talk about our journey building this data platform and how we scaled, because we had to scale in a short amount of time. And then some of the challenges and lessons learned. And then we'll go into how we actually use data to accelerate our growth. And then finally, I'm going to talk about how that all led us to building serverless and what that does, and how we've built that and are using that to scale the usage for our customers. All right, so let's get going. So a simple data engineering architecture would be, you have data in your data lake in S3. You run a single Spark cluster, and that Spark cluster takes this data, processes it through various stages, and finally makes it available for reporting and sort of in reporting tools and visualizations and things like that. Right, and this is like a very simple data architecture, but modern data architectures have more than that, right? If you look at what some of the large customers are doing, is they have not only data in their data lake in S3, but they have streaming kind of data coming into it, and they have sort of multiple data pipelines, many different Spark clusters running. They have complicated workflows where the output of one job depends on the input of one job depends on the output of others. So there's complicated scheduling, and then of course a host of different reporting tools that they need to feed into. But apart from that, all of this involves multiple Spark clusters, which means that you need to be doing workflow management, cluster management, and things like that using Kubernetes or Mesos or things like that. This is the kind of architecture we see a lot of organizations that are trying to build. And is the topic of how we did this today. So Databricks as a data platform provides that capability, that data platform that we're talking about, for thousands of customers. We manage that, right? And in a nutshell, there are two components to our architecture. There's a control plane, and then there's like this data plane. And the control plane is a thing that has, your notebooks, it has all the, SQL-related query engines. It has cluster management interfaces, configuration, security-related controls that admins would use or developers would use to build code. But then we have a data plane, which is where we launch clusters and VMs in a customer's network, in their VPC, and then we manage those VMs for those, for all of those customers. Now imagine doing this for thousands of customers. That's basically what we've essentially built and scaled out to. But apart from just doing this in one region, we've had to go to many different regions. In order to expand our product footprint across the globe, we had to do this not only on different regions, but even different clouds and different data governance zones. So we had to adapt our sort of practices and engineering practices to be able to do this rapidly in order to deliver value to our customers quickly. Now, that's the Databricks sort of control plane and data plane in a nutshell, and that's what we're going to be talking about. Now, the control plane has hundreds and thousands of users today. We have hundreds and thousands of Spark clusters. We are now up to millions of VMs launches per day. And we process exabytes of data every day. Some of our customers are processing petabytes a day, doing a whole bunch of mission-critical stuff on this platform. And this platform supports various different use cases from university students who are using our free community edition who've never used Spark, which is really popular, by the way. It's a great way to get started and gives us this pipeline of engineers who've been trained in Spark. And then we also have Fortune 500 companies on the other end doing this. So let's talk about some of the lessons that we've learned in building this thing in the next few slides. So, obviously, we didn't start with global scale. We had to start small. And so we wanted to start with something that provided value to our customers, but then eventually have the ability to quickly iterate. And since we are building this data platform for our customers, expanding those capabilities for our customers and what they could do with it was the main goal. So what we realized is that it's not just the data platform that matters here. The most important thing that matters is the factory that builds the data platform. Because if you focus on the factory, you have the ability to kind of evolve your platform over time with different tools and different capabilities and have the ability to iterate, which is more important than just building out the data platform itself. And so what were some of the lessons, right? So first thing is, what we did is we basically released our version 1 of our product. Our version 1 of our product was basically nothing but a few analytics tools. In fact, people used it a lot for converting like CSV to Parquet and things like that. But very quickly, we released a version 2. And the version 2 included job scheduling and management and all that. And the challenge of doing this in the initial days was how do we do this while people are actually using the data platform when we do this, right? When we upgrade it, when we want to add new capabilities, we cannot disrupt our customers from using it. So we had to do this iteration while they were actually using the platform. So the key to this was, the key to doing this was modern continuous integration, fast developer tools, and a lot of testing. We spent a lot of time optimizing our Scala builds. We increased our, we reduced or increased the efficiency of it 500 times than the default configuration. We have millions of lines of code for tests that run every day. And we have this ability to create a control plane in a box, which developers can use to develop features and test them. And now our developers have hundreds of these running every day to write new code and develop. What this allows us to do is basically keep adding features to our platform very rapidly and iterate. And we use Scala, Bazel, and React in order to do all of these things. Secondly, we wanted to also expand our global footprint, not just across regions, but also across different clouds. So the challenge is that each environment is slightly different. Not only do you have to deal with the quirks of the cloud, but also you have to deal with data governance and rules and policies in each place. And so, if you think about what it would take to automate this and deliver, again, features rapidly, it's a complex problem in order to achieve that. And so the key to success there was to focus heavily on declarative infrastructure and continuous deployment, right? So we use templates a lot at Databricks, and we use a templating language called JSONet, Terraform, and Spinnaker for our deployments. And basically, what this allows us to do is take configuration from millions of lines of code, and it comes down to much fewer lines of code that we can do and keep the whole thing simple, right? And it allows us to deliver new features globally few times a month. So our developers will build features and release code, and within 3 times a month, we can deliver capabilities to across the world. So that's what we had to build. Finally, we also wanted to expand the workloads that our customers could do, because one of the things is we deliver a data platform, but then as time goes by, we want our customers to do more with it. And so being able to expand the scale of what our data platform could operate, but simultaneously also add features to the data platform that more engineers could do and that they weren't reinventing the wheel. So how do you enable developers to build independently while also delivering new capabilities? And the key to that was building a service framework. A service framework was really important here because what we realized is that a lot of the work that these new services did, there was a lot of heavy lifting related to container management, APIs, rate limiting, and all those other things. And we had to abstract that away from individual services so that they could focus on the application logic itself. And so all our services, we use a host of technologies in order to do that. But what this allowed our developers to do is this SQL service team could operate independently to MLflow, and they could iterate quickly and build new services fast. Next was to decompose monoliths into microservices. We obviously started with monoliths because we had no idea where this thing was going to go. So for example, we had a cluster management in one VM that would manage hundreds of VMs for a customer. And obviously, that would not scale to the scale we are at today with millions of VMs. And so we had to decompose cluster management into multiple different services. We had to remove state from a lot of these services. And we had to kind of, make them redundant and reliable. And in order to do that, what that meant is taking one service and creating many different services out of it. And we had to do this for a few components in our product. So the service framework really helped us with that because it allows us to build those services much faster instead of making this a giant project that takes a year for us to build. Now, in summary, the Databricks platform allows us to kind of iterate. It allows us to iterate on our data platform quickly and replicate it in various regions. Now, one of the great things about having a solid factory is that you can use the factory to improve the data factory itself. And what that means is we use a lot of open source technologies today. As you can see on the graph, there's Envoy, GraphQL, and many of these others, Kubernetes for container management. But we didn't start out like that. Some of these technologies didn't even exist when we started building. But taking a factory approach allowed us to modify our tools and keep adding these new things without sacrificing on our velocity. So that was really key. Now we have a control plane, and we've built it, we've deployed it in multiple regions. We are delivering new capabilities on it. There's another part of this that was really important for us, which is how do you use data and AI to accelerate the growth of that platform now? And so it's really hard to operate a platform without data and AI in it, and there are various reasons you need to use data and AI to track usage, to do security, to do debugging, operational stuff. And so we had to invest a lot in building out these pipelines in order to kind of use our product to improve our product. So we use Databricks a lot internally. In fact, Databricks is the tool that we use to build our data platform that then builds our data platform. So it's kind of inception-like. So we need our data platform for features like billing, audit logs. We do feature usage trends, churn forecast models, service KPIs. Every developer in Databricks has access to these metrics, and every product manager has access to all the features that are being used, what their trend is, how well they're doing, and things like that. And that basically allows us to make the platform a lot better. And even Spark debug logs, for example, is we take all the Spark debug logs from all our clusters into a pipeline, and then we have the ability to analyze them. So that's like a massive amount of infrastructure. And to do all this, we had to build out globally distributed pipelines, right? Because we are, of course, across various regions. And so all of these kind of pipelines, we use declarative infrastructure like we did for our control plane. And this allowed us to deploy these pipelines so we can quickly iterate. And we have a templating tool called Stack CLI. You can check that out on our We have it on our website portal. We have a documentation for it as well. But we use Stack CLI to deploy these data pipelines and automate it. So when we come up with a new region, part of it is like setting up the data pipelines that are now going to collect all this data and put it into a central data processing engine. And so all of that data that comes from these regional control planes goes into a data processing engine where we use our product to clean it up, to process the data, make it available to different users for various reasons. We also then use different open source tools on top of that data, apart from just using our product like Prometheus and everything else, Jaeger and all of that for distributed tracing, and our developers have access to it. And so the key in all this was, again, making sure that it's automated, that we use declarative infrastructure to deploy it. This has allowed us to now, I remember when I joined Databricks, we to set up a brand new region used to take us like a month or more, maybe more. And that was a big business inhibitor because we'd have demand in all regions and be like, yeah, this quarter we can have only one region launch. And that used to limit us a lot. Now it's down to like under a week, we can deploy a brand new region. We have everything automated and then we just do a bunch of, we leave it running for some time so that we make sure everything's running before we deploy it. So that's what that's allowed us to do. Now that we've built this infrastructure with control plane and data plane, what we realized is that we have a lot of customers that became really successful using Databricks. And what we see is that the customers who are actually really successful were the customers that were able to make all of their users get access to all the data they need in order to do their job. And this is fundamentally what's happening right now, is you start with one use case, which will be quite simple, but then they quickly realize, hey, I can use this to do a whole bunch of other things that I actually need to get done and grow it across these use cases. Some of our customers, save, lots of money in, $1 million plus in like fraud detection, every couple of weeks. We have customers that have built, new liver chronic disease drugs based on top of Databricks. We have a lot of retail customers that predict, there's also the recommendation engine from large streaming providers. And so the way they've gotten to that stage is by scaling their use of Databricks and scaling the use of data. But the challenge, what we realized working with these customers is that the next level of scaling, comes with a set of challenges, right? In order to do all of this, you're essentially managing a lot of compute. A lot of teams need to be able to process data, which means a lot of VMs are getting launched. And that just means more infrastructure. And if you kind of think about it, what the challenges that come with managing infrastructure is that how do you give access to instant compute to users? If you're building a data platform, things you're going to realize is people don't want to wait. So how do you do that? How do you make sure that you're compliant? Like you're going to be processing data of different classifications and things like that. How do you make sure that you're not violating certain things and exposing yourself legally? And then performance and cost management is another aspect. One of the things we realize is that as customers start using it initially, they're like, yeah, this is awesome. And then you hit a point and they're like, wait, things are getting expensive. You're using it across all these teams. How do we kind of control how to control cost, who's spending how much, what projects are really useful. And so for all of those reasons, we looked at it and we identified, okay, there are three kind of areas that we need to start addressing and three kind of challenges we see, right? So I'll go a little bit into each of these to tell you what our customers were saying, and then we can talk about how we are addressing those and scaling that. So the first one is for instant compute. It takes about 3 to 5 minutes to launch an instance in AWS. And so if you said that anytime a developer wants to execute a query, we're going to launch an instance, you're going to have to wait, right? And engineers and analysts do not like to wait. This is one of the sort of key feedback we have is that we don't want to, when you're developing and iterating code, you don't. Now, you combine that with the fact that 80th percentile of all jobs that run on Databricks complete in under 5 minutes. So if it's going to take you, 5 minutes to launch an instance and 5 minutes to run your job, it takes too long. And so that causes a lot of friction. And in some cases, teams have SLAs. For example, we talk to customers that say that we have to promise and give an SLA that a query is going to complete in under 1 minute. And so how do we do that if we have to wait for a cluster to launch every 5 minutes? And the typical answer we've seen, what we see is that people just leave it running all the time. And that's the only option, is that run, compute, and make sure that if people are running, doing data science, whatever it is, like they will share the cluster and then leave it running all the time. But then that has issues related to cost, right? Because now you're running something 24/7. So the challenge here is that if you want to give compute instantly to your developers, you have to run it all the time. So this was one thing we wanted to solve. We were like, okay, how do we scale this pattern? The other thing was security and compliance. If you look at it, in this model, in our architecture, we have clusters getting launched in customers' VPC. In fact, a lot of our enterprise customers, kind of like this model because it's in their environment and things like that. But what you see is that when you launch something in a VPC with many different VMs, you're going to have to worry about firewalls, data exfiltration, what ports are you connecting to, how do I know my data is not going out of the wire to somebody else, and those kind of things. So you now have to put those controls. There's also compliance and monitoring that you may need to do, right? So what's going on these VMs, who's logging in, is there any anomaly going on here? Because the number of VMs that we're talking about is large, right? And so it represents a large footprint of compute in the enterprise. And then there's the infrastructure operations, right? Like in general around, okay, you are creating a VPC, you're managing that VPC, the network, you're managing the VMs in it. It comes at a cost of upgrade and other things like that. So it basically requires you, now if you think about it, if one team is enabled with one VPC and then you have to scale that use across all of your different groups in the company, you're in a stage where you're managing a lot of that infrastructure. Some of our customers have in the order of hundreds of VPCs, that they are managing in order to do this. Every team gets a new one, right? That's how the model works today. Is like in like Amazon and other like basically AWS says that, hey, in order to do your billing and everything, make sure that you give one team one AWS account, and then the billing and everything is super clean. But that means that every team gets an AWS account, which means every team runs clusters in their environment, and hence that means managing more. And so this was one of the things we saw, and we were like, hey, now to go to the next level, if everybody is going to use data and AI across thousands and thousands of employees, like what does that look like? Yeah, so scaling to all these users would require you to scale your operations. The third one was around performance and cost management. This is interesting because if you look at that same paradigm, for performance and cost management, what you're doing is you're tracking the usage. So you run queries, you're running jobs, and then you track how long that job took, how much money it spent, or how many resources it took. And then you monitor utilization. Am I using the right instance type? I ran a cluster with like large, and maybe I'm using 30%, and I'm spending all this money. Is there a way to make it cheaper? So you have to and then you have to configure the cluster policies or spot policies for that. You know what? Let's do some pooling. Let's make sure we use spot when it's when it's best to use spot and things like that. This is something that most customers would have to do in order to be very fine-tuned with their cost, right? Meaning understand exactly where what is spent and bring it down. And so a lot of our customers, today, we don't see a large amount of sophistication here, where we see very few customers who have have sophisticated operations around figuring out where where money is getting spent and how much utilization they actually have on these things. And then again, when you scale this out to, across all your teams, how do you get this view, right? Like, how do you get, like, these 20, 30, 40 teams, how do we kind of build this infrastructure that's going to monitor the cost across all these and make recommendations and things like that? So these were the three things we saw, and we're like, the next wave of scale requires us to invest in infrastructure that allows our customers to scale the use of data and AI. That's what's going to make them successful and us successful. And so we started building Databricks Serverless, which is basically, we could provide tools. One approach was we could provide tools to these companies to say, hey, here's a cool pooling policy engine, or like, here's how we can easily integrate with Spot. But because managing this across these hundreds of teams or whatever was going to be hard, that approach seemed like, yeah, it's going to go part of the way there, but not really solve the problem, right? And so we wanted, and that's how we invested in serverless. Now, the high-level architecture here is essentially that the data in your data lake still resides in S3. So we tell our customers, like, keep it there. But the clusters and the VMs that process that data are running in a Databricks account. And what we take on is security of those VMs. We take on, if you're running regulated workloads, we would, obviously do the compliance and stuff for that. And we'll take on giving you access to instant compute. And then the data is in your environment. It's in open formats, so you're not, essentially locked in any way. One second. Yep. Yeah. And so at a high-level architecture, we have a concept of workspaces in Databricks. So for each customer, each customer gets their own network we call it a logical perimeter. It's a combination of having rules in the OS level for, at a privileged level for disallowing communication between nodes outside the cluster and security groups. And so what we do is, we keep a pool of ready instances, and we put them in a separate security group. And then whenever you need VMs to be assigned to a customer, we move them to a different security group. And then that security group will be given, those VMs will be given sort of instance profiles and IAM rules that allow access to a bucket in the customer environment, right? We never reuse VMs across customers at all. So first of all, we have VM level isolation for our customers, but then if we get done with a VM, basically we just give it up to the cloud provider. We don't recycle it. We just take a brand new VM and do it. So this allows us to have like 3 sort of layers of security, right? We have the sort of OS level rules that do that. Then we have the security groups and networks that we create. And then there are different VPCs that we create to isolate further. But this is a multi-tenant service, meaning like a VPC would have VMs from different customers running in there, but they'll all be strongly isolated. We are investing a lot in making this super secure. We are investing in container isolation technologies like Kata, Firecracker. We are working very closely with the AWS Fargate team on different ways we can actually make this more secure. We also have a lot of security in the back end on these things where we monitor what's going on these things. We have agents running on those nodes that kind of do a bunch of all the integrity monitoring and things like that. And that is key, right? Because I think the key to nailing serverless is actually getting the security right. And once you can get that isolation right, that's where you get all the utilization and cost benefits, because you can be very flexible about that. Now, what we do in this environment, in this data plane, is when somebody runs queries or somebody has a cluster launch that happens on behalf of something they're doing, like running a query or running a job or whatever it is, we basically we launch these running clusters. We look at what these clusters are doing in terms of utilization. We start learning. We are collecting data on that, and we are learning from that data. And then we start predicting, like, hey, in the next n minutes of interval, how many machines am I going to need ready in order to service customers? And we keep that pool. We keep that pool of instances up and running in a quote-unquote warm pool, so to speak. And anytime somebody needs VMs for a cluster launch or running a query, boom, we give it to them in seconds. And this system relies on us. And the reason we're building learning into this and not staying with like manual capacity management and other things is because at the scale at which we operate, we cannot do that. We cannot just say, let's take a bulk set of VMs and just keep them running. It's going to be too cost prohibitive. So we have to be intelligent about, we have to be intelligent about the patterns of usage of these VMs across different customers, and then figure out strategies around allocation. This also means that there's some level of abstraction that you're going to get. For example, our customers don't no longer say i3 large or whatever, right? They're going to just say, hey, I want a compute optimized instance or compute optimized cluster, and we'll figure out what instance type needs to be used. Now, from that data, in the near term, we're going to be able to do things like scale clusters, usage, managing spot fleets and policies for our customers, on behalf of them, so it's easy. and also auto-terminate frequently to save cost. We've delivered SQL on serverless today, and it auto-shuts off within minutes. And so anytime you see idle activity, your cluster goes away. When you go back, your cluster is back up in seconds. That is the power of this thing. And so that allows you to save cost because you're not leaving things running around. Classic example of this is we spoke to folks and we're like, how often do you want this to terminate? And it's like the typical time is like 60 minutes. Not for auto termination. They're like, we have people who go and come back and to a meeting and they want to start working on code, and the cluster should be up in seconds. And so anytime like you take a water cooler break for 10, 15 minutes and come back, you don't want to pay for that amount. And so that's what we're doing is in minutes it gets terminated with idle activity and then it comes back up. And the future is that we are going to be able to adjust your instance sizes and cluster sizes automatically. And we'll be able to efficiently schedule jobs and reduce cost. And what that means is, if you talk to our customers today, they're like, "Hey, we run many different jobs, but I don't go back and check what this job is costing." So we ask them, "How do you know? Like, how do you optimize on this?" And they're like, "Well, 3 months, like every month or so, we'll go back and see how much is this. Man, that's expensive. Maybe we should try reducing the instance type and see what happens. Maybe it still works well and it's cheaper." But that's a manual process, right? So what we intend to do is we intend to be intelligent about those things. If we see that there are certain things certain kind of jobs that are running, but they could run on a cheaper instance, we'll be able to provide you that recommendation or do it automatically. So it keeps going. Or even do things like, oh, we ran this, and this is the ideal profile for running this job because we ran it 3 or 4 times and say, you know what, like, yeah, this is the best config for this, and it'll automatically apply that for you. But those are the kind of things you can do once you're managing kind of compute. And basically what it boils down to is simplicity. This boils down to simplicity, and simplicity helps you scale, right? If it's easy to operate and build data products, you're going to be able to do more of it, and it's just that simple. And so parts of our product that are going to be directly impacted with the serverless, which will allow our customers to do more, is we'll have a much more simpler notebook interface to be able to build and iterate on code, right? Imagine getting in, it's like opening a laptop, right? You go and you start typing stuff in Google Docs. You don't wait for a cluster to start up when you're using Google Docs or Google Sheets, right? It's the same way. You get in, the developers can get into work. There's a VM already that runs based on, when they get in, and you can easily run notebooks without having to worry about infrastructure. Today, a lot of these decisions have to be made. For example, you write a piece of code, and then you'll be like, okay, how many CPUs do you want for this code? That, in my view, is just like ridiculous. No developer knows I need 4 CPUs to run this well, right? And so I think giving that option even is just strange. So interactive data science gets a lot easier because now we just, we are handling the VMs. We are like, yeah, we'll take a generic one. If it's not working or we see that it needs scaling, we'll do that appropriately and behind the hood. We released our SQL on serverless this year. We have compute in case starting seconds. Our SQL endpoints start in seconds, and easily, you can run queries on them, and you don't manage the compute for it. So you get a choice of small, medium, large right now in SQL, and based on the small, medium, large, we figure out what types need to run. We are transparent about what instance types we are using right now, but in the future, we're going to be able to shift those based on how we want to achieve our efficiency and cost. And then it also simplifies model serving, right? Because scalable model serving, because you can build models, you can put them in production, and you can serve them, and those, scaling those sort of endpoints that are serving these models can be completely transparent. We use Kubernetes to do this, and it just scales horizontally. So it makes it super easy. So abstract away the compute and manage the availability and scalability of that whole thing. So it ties in serverless is not just a SQL queries or Spark query thing. It's more about having compute available in order to kind of integrate all these workflows together. And then basically, it simplifies data science and machine learning because what we see is that having something like this allows you to focus on other things. Imagine in some of our customers, the number of people who would kind of be involved in the operational aspect of these clusters of VMs, or the ones who would actually be responsible for managing the cost and other things. you can use that time of all these people and put them towards actual real projects that are more focused on ML and data, and it takes away that component. This problem is not as much in smaller companies. If you go to mid-market segment, it's not that big an issue. But when you go to enterprise, like they have teams of people that are responsible for compliance of infrastructure, monitoring, and all those other things. And then having that just prevents the engineers from moving fast, right? Because they have all these dependencies, and it just takes that away. So yeah, I mean, in short, like that has allowed us to kind of go and scale, right? This is Databricks in 2018 versus 2021. We've gone from like a few million, cluster launches to about 60 million cluster launches a month. We do like two something million launches, cluster launches a day at this point in time. And of course, as serverless comes out and we support other parts of our product on serverless, apart from SQL, we see those VMs kind of moving from that direction into, into a serverless model as well. And yeah, so in summary, we process millions of VMs. We've learned several important things. Building a data factory, super important. Building service frameworks that allow developers to go and build independently, so you utilize their time fast, and then being able to use data to actually scale the platform, eventually leading up to kind of building something like serverless. Now that you've gotten into a world where you're focusing on building the data products that add business value, and you can scale it from 0 users to like thousands. Like some of our customers have like 8,000, 9,000 users on this product within a single company using Databricks. So yeah. You can try Databricks at databricks.com/trydatabricks. I will be here along with Ihor if you had questions around any of the details you heard or like directional stuff of Databricks. I'd be happy to sit and answer any questions right after this. Thank you. By the way, we also have a mic here in case somebody has questions. Otherwise, I'm right here if people don't.
Hey, Vinay.
Hey.
Andy from Databricks. How you doing?
Good.
What if you were doing the same again differently? What would you do?
You mean?
Sorry, if you were doing the same thing again, what would you do differently in terms of scaling out Databricks as a service? Might be one for Ihor.
Well, yeah, that's a good question. Well, let me see where to start. It's kind of difficult to say in retrospect because, for example, if we were starting Databricks today, there is an abundance of tools, services, platforms, open source technologies that we would build on it and probably would get, where we are much faster. But it's difficult to reflect on something from 7 years ago because things were in their instance, things were in their infancy, and a lot of times very early on and didn't even exist.
I think if we started building the frameworks that we're building today as a company, and we started them 5 years ago, even though those are frameworks required for scale, we probably would have failed as a company. We wouldn't be where we are today. The reason we are able to do it is because we did what was needed at that time in that shape or form, while realizing, like knowing that the puck is like eventually we're going to need this. So the data factory service framework thing was really helpful in order to do that. I also think reflecting back, like maybe we would have gotten into doing more serverless earlier on. Just because I think it's one of those things where simplicity, like Databricks is a technical product, right? And so having that layer of simplicity would have helped earlier.
Yeah. I think that's correct. I mean, early on, we started in a way that allowed us to iterate very, very quickly. And in some of these cases, we built services and infrastructure ourselves, as opposed to taking product that is not yet fully baked. And it helped at the time. We didn't wait for the dependencies to mature. Yeah, I mean, aside from making some different architectural choices internally, kind of too many details, but I don't think we would do that much different.
Yeah, and one data point is it's working, right? Whatever we did, I mean, it's been going from 0 to 60 million. So in that sense, yeah, smaller things, but the big scheme of things, it's worked out.
Any other questions? Nay, Hor, thank you so much.
No, thanks, guys.
Thanks so much.